Hello everyone. Today's video is based on our webinar when AI agents get the key to your network in April 2026. And during this webinar, we covered quite a large amount of various topics and concepts. And due to limited time, we weren't able just to dive deeply into details, how it is, how the environment, the demo is prepared, configured, and implemented. So we decided to split the content of the webinar into three parts series, and in which part we are covering a part of the concepts from the webinar. We are revisiting them, but with much greater focus on implementation details and configuration details. So this part is about attribute-based access control and end-to-end auditing. My name is Tomasz Janaszka. I am solution architect at CodiLime, dealing with projects focused on deployment and applying AI and machine learning techniques to solve various challenges regarding network and IT infrastructure. So let me recall our major problem that you would like to solve. And in the world of the agentic applications, AI agents, we considered the system when the user is acting on the network devices via agents that interpret the user intents, and via the MCP tools exposed by various MCP server are able to retrieve data from network devices or do some actions on network devices. So our assumption is that we would like to assure that the agents and all the involved components must act only within the user permissions that could have different roles. And also, we would like to assure that those agents can only inspect the network devices or act on network devices that are authorized for particular users. And also, we would like to achieve that it is a quite complex execution path. We would like to have the proper audit logs in order to prepare audit trails in case of various incidents. And in this part, we mainly focus on the two objectives that are bolded here in the slide. In terms of the gaps that we identified, we would like to limit the confused deputy problem on AI agents, but this time in terms of the which devices are reachable by particular users for which AI agent is acting behalf of that users. And we also focus on the proper preparation of audit logs and at the end the trace. So first topic is attribute-based access control. After just securing or introducing identity provider and proper tool access control at the MCP server, then we covered the generation of short SSH certificates and all the configurations that allows us to log into devices with proper, say, permissions and with the proper command authorization at device and at device level because of the problem of the danger of existence of some gaps in the MCP tools. But this time we would like to extend this architecture, providing the policy engine that is able to deliver information if that particular user can reach particular network device. To do so, we introduce the open policy agent, which is the, say, central policy enforcer. That is open source. It is using a high-level language for defining various policies and very complex in quite convenient way. Also, those policies and the data based on which the policies are being enforced could be versioned and also tested separately from the logic of the whole system. So the separation of the policy enforcement and the logic of the application is the key point here. and how it works in our setup is that MCP server, after checking if particular user has rights to execute particular commands, next is asking this open policy agent whether this command could be executed on particular device, and the policy should answer yes or not, depending on to which devices Alice, Bob, or Mark are authorized. So in a very short description, this open policy agent evaluates some additional attributes that we could embed into the JWT token for particular users, and usually against the device and inventory that we have in our network setup. How it works in the flowchart: when a user asks the query to the React agent, there is a process of reasoning, planning, and determining which tool with which attributes he would like to execute, communicating with the MCP server. MCP server, as before, just validate this token, validate inputs to this particular tool, and check the role-based access control by applying this provided earlier decorator required scope check. But if it all passes, the next step is just to ask whether this particular tool can be executed on particular device. To do so, the MCP server is forming the query, the request to the open policy agent, just wanting to receive if for this particular device, this MCP server can communicate and execute the commands that are inside particular tool. And so we have another check, and depend on that, we communicate with particular network devices receiving response, or there is a denial that with some important information that the user and is not authorized to reach this particular network device. So if we switch to our, say, demo application, so we would like to demonstrate it. And this time we will introduce some additional attributes for particular users. Those attributes are allowed sites, allowed environments, and allowed tenants, which means that we configured the rights for Alice only to see the devices in Denver site, only production devices, and only for the tenants ACME. For Bob, we defined that it could just investigate and operate on devices in Denver and Seattle, in prod and lab, and also for one, say, tenants, and also for some shared devices. And of course, Mark, our net admin, is able to operate on all the devices in our network. So let's switch to the application, and we here are logged as Alice. And we have the special button here that we could just toggle on this device filter using attribute-based access control. When we switch it on, then we could see that our token is extended by some additional attributes related to allowed sites, allowed environments, and allowed tenants. So clearly we need to define some attributes, some groups, whatever we want to here to reflect that particular user has access only to the limited subset of network devices. We need to properly configure it in our identity provider. And after switching it on, then we could run a simple query via chat, which is communicated with the agent, and agent is selecting appropriate tool and trying to run this tool on this specific device that we provided in our query. So this time we will show the BGP summary on Denver spine 01. And as I mentioned earlier, Alice is authorized to inspect this node. When I run it, we should get the response from the device about BGP. So we got the response, but let's try to do the same query, but this time for our device in Chicago, spine 01. So it is not authorized to do so. and we should have got the clear message that this is the, say, attribute-based access control. It is denied because Alice cannot access devices in Chicago, in particular this one. So we could see that it is being working that way. And in a minute, I will explain how it is work under the hood. But using the open policy agent, as we mentioned, that this policy enforcer is just checking the network inventory, so devices with some attributes associated with particular of them, and the attributes associated with particular user. And this mapping and checking is quite easy to do, but let's say that the inventory is not changing very often. But open policy agent could also be served with some dynamic say states. And here we would like to present that as a network administrator. If we have switched on this device filtering, so attribute-based ABAC control, as an administrator, we can also toggle on the maintenance window. And at this time, using the same, say, application, the administrator can do some, say, repairs, ask some statuses, and tries to find some problems and to reconfigure, etc. So, but during this activity, he do not want to be interrupted by other, say, activity from other users. So this switch is working like that, that the maintenance window is on, and this data is reflected dynamically in the open policy agent, so that other users of the same application can immediately see it. And what is more important, this without any restart, we will see that they will not able to operate even on the devices that are authorized for them. So let's try. Let's the first question as a mark. Let's display some information from one of our device. So we got the response, but now let's just switch to the Alice and try to ask the same query as before for the node in the Denver. So normally Alice is authorized to inspect this node. And if we try to run this query, immediately we got the answer that there is a maintenance window active. So we cannot access this device at this moment. And after admin just finished its work, I can switch off this maintenance window, and in a while we could be able to execute this command as Alice. So pretty straightforward, but I would like to stress that not only the, say, static comparison with the inventory and attributes for a particular user, but also some dynamic data can be used, utilized, and we demonstrated it in the form of the maintenance window. So let's summarize our demo. So we use open policy agent to realize attribute-based access control to limit or to model the rights for particular users to access particular subsets of network devices. Of course, we would like to, in case of denial, to receive the proper justification why it is like that. So seeing some information about that this particular user is not allowed to reach particular device. And we also demonstrated on a simple example that this open policy agent could work on the, say, dynamic data. In this time, the simple switch defining the existence of the maintenance window provided only by the network administrator. So in order to do that, we just introduce the open policy agent component. We also need to add additional code at the MCP server, and we need to extend the attributes in the user token at the level of identity provider. So first, it is pretty straightforward. Besides the previous attributes associated with particular user. We have some custom attributes, and this time we introduce 3, defining the list of allowed site, environments, and tenants for particular users. And what we need to do additionally, we need to define additional protocol mapping in order to finally embed those additional attributes and the values into the JWT token per user, which is signed and utilized by MCP server for additional check. And on the open policy agent, we need first to deliver the data. So our basic data here is devices. For each devices, we have, for each name of the devices, we have the site, environment, and tenant field. And we have a kind of dynamic data, meaning that whether it is switch on and or off the maintenance window. So next, MCP server trying to, just before the execution of particular tool, it's just creating the input to this OPA server and also provides the attributes for particular user, but also devices which are planned to be used during the execution of particular tool. So this is the MCP server side, so we need to organize such a request to the open policy agent. And inside open policy agent, as I mentioned, this framework is utilized the high level Rego language to define rules. And here we could see the helper rules. One of the rules is site allowed for the device if this site of the device in the input user allowed site. So input user is just the attributes that are pushed during the execution of the tool by MCP server. So just simply check whether this site is in allowed site of particular user. Similarly, for the environment, for the tenant, if we have some tenant that are marked as shard, so we can just also define whether this is the shard, so any of the user could just at least to inspect them. And another rule for whether the maintenance is active, if not, is just simple checking if our dynamic, say, variable maintenance enable is true or false. And compound rules are for particular devices and for the particular users that are injected during the request to the open policy agent. And good point of this, say, Rego language is that we can just name the particular rules using the same names, and in that way it is the OR notation. So when there is a check for network administrator, so this is just checked if it is in the role and if particular device is available to the net admin, is the only condition is that this device name is in our inventory. So, but for other users with different, say, roles and attributes, in that case, we just execute particular helper rules, and this notation is end. So all if of for particular request, if we have device name for particular user, first we are checking if the maintenance window is active. We are retrieving the information about the device, and we are checking if the site is allowed for particular user. Environment associated with device is also in the allowed environments for the user, and the same for the tenant. So it is quite convenient way and very flexible language, Rego language, for defining various rules. And we used here in our example for the attribute-based access control. And in the MCP server, we just introduced another decorator, required device access, that is put before any kind of tool. And what it is, this decorator is before executing particular function to particular tool, is getting the token access of the user, is constructing the input to the open policy agent together with devices for which this particular tool needs to be executed. And there is a request to the open policy agent, and we are receiving the result with the devices that are allowed or denied for this particular tool call. and this particular moment. So if we do checking for Alice and we are considering some tool working on two nodes in Denver Spine 01 and Chicago Leaf 01. So here the open policy agent will just check that the Denver node is possible to be reached by Alice, that Chicago is not in the list of the allowed site, and also the tenant is here Globex, which means this is not the same as ACME, which is for the Alice. So the response is that we are using the batching because many of our tools are utilizing the multi-device approach, so can be spread or sent and executed in many devices in parallel. Therefore, we, from the open policy agent, we just received the JSON with the allowed list of devices and denied. And for each denied device, we also are adding some meaningful message why this particular device is not allowed. The reason. So this is regarding the attribute-based access control. So now I would like to switch about to end-to-end auditing. And what is the problem? Because when we have the incident, we would like to quickly know which user or which agent did or decided to execute particular tool and do some command on the device that could be problematic in sense of our, say, incident. And we would like to discover who permitted what in the sequence. So in order to do that, we need to carefully prepare some auditing logging in all our components, and we are doing this in different ways. I will show some details, but first let's demonstrate. We should think about what correlation IDs we should use and propagate across the entire execution chain. For many services, we need to think about how to inject them just for the auditing purposes. And at the end, if you would like to provide some traces, what was, who did what, it is good just to gather all these audit logs from different components from different sources and to place in unified form into, let's say, one central audit log server. So this is the problem that you would like to solve. So first, the correlation IDs, based on which we would like to group some activities and to easily answer the question what was done or permitted at which, say, service, subservice, or component. So we have, of course, the user, we have its role, we have the session that always provided by our identity provided during the logging. And of course, we have the agent ID because it can be different for different users because they are different roles. And we have the request ID, which is being created during the particular tool execution. And we have the credential because during the execution, we are just creating the short-lived SSH certificate and at least the serial of this certificate we would like to use for the correlating the various actions. So, and how it is propagated. So, in fact, we are starting with the user role and session from our, say, identity provider. Those fields can be injected into the agent during the logging, just to know for who this agent was being created. After creation of the agent, we have another identity can be injected into the, say, MCP server, because MCP server can collaborate with multiple agents, so this is the important. But when this MCP server is executing the tool, then there is tagged by specific request ID that also could be injected into the consecutive components like open policy agent. And when we create in our certificate manager the SSH certificate, its identity also can be embedded into the device and even to the attack server having all these IDs, just for the auditing purposes. And at the end, if we do some configuration in that way and we assure that we have the proper logging in particular components from different sources depending on where the, say, audit logs are finally destined, then we use in our setup some additional component like syslog ng server and prompt, and just to uniformly transport them to one server. And this way we use just Blocky server. In the demo, let's demonstrate how it could look like. Just switching back here, we just prepared the additional security audit. Of course, it should not be here in the application, but just for the convenience for the demo, we just added another panel. And what we here could see, it is the raw log. So the raw log is just the collection of these audit logs from different components like agent, TACACS, particular device, OpenBAO, which are certificate manager, and of course from particular MCP servers, collected in the way so we could just extract the fields like agent, session, user, role, and all the particular fields were just selected or properly extracted from the details. In those details, we assured that all those IDs were present during the logging on that particular components. But of course, it is much more convenient to prepare the trace view. So we here could see the audit logs grouped for particular users and for particular queries, for particular prompts. And let's just look at our, say, execution when Alice, as our net viewer, just show BGP summary on one of the device. We could easily see 10 steps, and AI agent just permitted to serve this query. And after the reasoning, it selected the show BGP summary tool. So we also just logged that this tool was selected to be called. So next tool request is coming to MCP control plane. That is checking roles-based access control, whether this tool is allowed for particular user and it is permitted. If so, next is asking if this particular device in Denver can be reached by Alice, can be inspected. So we have the response from the OPA, which is permitted. So after that, MCP server is confirming that it is the permission from the open policy agent. So it could just initiate the execution of tool. To do so, just to communicate with particular device, it communicates with the OpenBAO, which is our certificate manager, just to log and to achieve the just-in-time certificate, which was permitted, so successfully delivered. And after that, we have some actions checking these commands on the device level with the delegation to TACACS, which also permitted to run this particular command on this device. And at the end, we have the response with the success. But of course, we could also look the previous call, which was denied. And if you remember, we just tried to do the same command on the Denver during the maintenance window. And this time, OPA, Open Policy Agent, just denied due to the maintenance window. So the MCP control plane, after denial from the Open Policy, just stopped executing this tool, and the response delivered to the agent was denied with proper message that this tool cannot be called. So this is very important, just to think about proper logging and auditing from the beginning of setting up some agentic application, MCP server, and so on. Now I would like to focus and to provide you some details about configuration on particular components. Of course, we are just auditing our identity provider when the user is being logged into our application via our identity provider. We could report useful events. Of course, just configuring also some loggers and event listeners, depending on where we would like to transport those audit log lines. Useful IDs are, of course, user ID and session ID. And we could see some, during the logging to application, we could code to token, which means that the JWT token was successfully issued for the Alice. And we also have the user ID of the Alice and the session ID that we are just propagating during the execution of particular, say, intent of the users. So this is the kick log. In the net expector, what we would like to log, of course, we would like to log when the user provides a new prompt together with all these correlation IDs here. And also when agent selects particular tools to be executed. So we could extend this log by the tool name and of course the arguments, which is important. And at the end, we would like to provide the status of the particular tool execution or the response. So these are examples of logs that we would like to achieve. Of course, timestamp is but this is the info audit. This is the type of prompt for particular user, some additional correlation IDs. And what is important, we could just see the query asked by the user. But during the execution of the, or just serving this intent of the user, we could have many tool calls. So each of them need to be traced just to know what tools this agent decided to run to answer the user query. So this is the second point. Of course, in the MCP server, we have a lot of IDs that we need to use in our logging, but minimum at two places when we are checking the role-based access control to tools. We need to provide if it is denied or allowed based on the user's role and the scope required for particular tool. And another point is that we would like to log after the receival of the decision whether this particular device could be reached by particular user. So it is the stuff related to attribute-based access control. So a kind of examples of the logs, of course, definitely we need to log stuff related to role-based access control and attributes-based access control together with other correlation IDs. Of course, in the open policy agent, it is quite straightforward because we need just to configure this component to log to console or to ship those, say, decisions logs into, for instance, our, say, Loki instance directly. We could do it configuring very light, say, service just to forward this log lines directly into our, say, destination, final destination. But the open policy agent is configured just to provide the logs with all the input. So it was prepared by MCP server. So user, session, agent ID, allowed site, and other attributes, and to what devices, and the result in the log tells if it is what was the allowed, say, devices and what was denied with some reason why, if denied. So this is the pretty straightforward. We need not to configure much using the open policy agent, but all our input and result will be just automatically logged. If we consider Open BAO, our certificate manager, there is a little bit complex to achieve good auditing because here, if you would like to exchange our JWT token of the user to retrieve the SSH certificate, then we are providing some additional information about the session, user, and agent in the special key that is the key ID, let's say. And by default, this certificate manager is hashing those information. So by default, we could not see in the logs our correlation IDs. In order to do that, we need to just tune the secrets and just provide some option, no HMAC, which means for particular, say, fields that we can declare. And then after that, the fields that we injected into this component will be present, and we can just correlate them when we are creating the audit traces. But we need to do that, but if not, by default, we just see here the hashes instead of those. So it is quite important if we also want to see in our traces that the SSH certificate was issued for particular context, for particular user, agent, and session, user session. At the device level, of course, we need to configure the SSHD, just first increasing the log level to verbose, just to see the events related to the authentication. So when our MCP will connect to particular devices, so we would like to see such events. Also for our purposes, we need to expose this authentication info in the special environment that could be read, for instance, by our, say, shell command validator. And also we need to configure some environment variables that could be injected after the establishing the SSH session and used in our validator and operation at the device level. So here, for instance, we would like to inject request ID, which is not present in the certificate because it's created by, say, OpenBAO. So we need to configure what we would like to inject. And in our validator, of course, we need to log the information that we could retrieve from the certificate and from the additional environments that we allowed whitelist here in the configuration on SSHD. And example of, say, syslog that we could see on the device is the first is the successful login with all our correlation IDs. And the second point is just the logging of the whether particular command was permitted or not. And here also we can just inject our correlation ID to create the useful traces. And the last point is what we could do in TACACS, because also we would like to have such a logging on the TACACS server. And here it is a little bit tricky points to achieve that, because we cannot inject directly additional fields when we are requesting the checking the command authorization by TACACS Plus. So a tricky point is just we just find in this say TACACS package some field which is the remote address, and usually it is the field is used to show the remote address of the users. But in our case, MCP servers are communicating with the devices, so we exactly know where the addresses are, and it is not for us so much important, much more important just to inject all our correlation ID in this field, and that would be automatically logged by TACACS Plus server. So the TACACS Plus NG allowed us just to, without any changes, only just injecting, preparing the TACACS package request, we could just inject those our correlation, and we have automatically logging on that server and can use to create traces. So quite a lot of configuration on different components, and sometimes we need to use some tricks just to achieve our final goal end-to-end auditing as we demonstrated. So we need to, of course, to think about that our, say, access decision should be much more dynamic than static, and attribute-based access control enables to create the rules that are much more context-aware than simple role-based access control. Definitely this framework is we used here for attribute-based access control, but also could be used for role-based access control. And if you want to build only one single port of truth for the access rules to devices, to tools, we could use it conveniently. And of course, we need to think about how to log particular actions on particular commands just to be able to create quickly some traces in case of the incidents. Key takeaways. Doing this protection, try to use the dynamic roles attributes instead of, say, static roles. Makes a decision about the access to particular resources context aware, not only based on the identity. Of course, think about correlating the actions, providing some metadata and correlation IDs. in order to see the full audit trace when our agent is collaborating not only with the devices, but also with other resources. So this is the takeaways, and I think this is the sum up our, say, last part of our series. So I highly encourage you also to check out the previous parts. You can find the links to our webinar as well to each particular parts under the video. So please, if you think this is valuable to you, just check out them. You can contact our company via this email, contact@codilime.com, and thank you for your attention, and bye-bye.